An engine management system such as OBD2 can be divided into three main parts: the inputs, or sensors, the processing unit, or main computer, and the outputs, which are primarily fuel injectors, ignition coils, and transmission shift solenoids. The input sensors monitor a wide variety of conditions that could affect engine operation. The sensors feed this information via voltages and resistances to the main computer. The main computer is programmed to analyze all of these inputs simultaneously and make determinations on how to alter the fuel ratio and ignition timing of the engine, as well as when to shift the transmission to another gear. Let's talk about the critical conditions that input sensors need to monitor for proper engine operation. The first is throttle angle. Obviously, the computer needs to know how far the accelerator is being depressed by the driver. This will be a large determining factor in how much fuel the computer feeds the engine through the fuel injectors. The throttle positioning sensor is the sensor that monitors this. This sensor mounts on the side of the throttle plate on the engine. The next input is engine temperature. A cold engine needs more fuel to run than a warm engine does. Therefore, the system needs a way to monitor engine temperature. The coolant temperature sensor performs this job. It threads into the coolant jacket of the engine and constantly monitors engine temperature. The next input is air temperature. The air that is being taken into the engine can obviously vary greatly from winter to summer and region to region. Colder air needs more fuel to burn efficiently than does warmer air. So an air intake temperature sensor is used to monitor the temperature of incoming air. This sensor will be located somewhere in the air intake ducting or intake manifold. In addition to the temperature of the air entering the engine, the computer also needs to know how much air is getting to the engine. To operate efficiently, an engine must have the correct air-fuel ratio. This is typically 14 parts air to 1 part fuel. The way the engine management system knows the amount of air entering the engine is through what is called the mass airflow sensor. The sensor reports the amount of air entering the engine, and the computer will adjust the amount of fuel accordingly. Two more critical inputs are the position of the crankshaft and camshaft and their rotation. The computer needs to know the position of each so it can determine exactly when to fire the coil and fuel injector for each cylinder. There are trigger wheels attached to both the camshaft and crankshaft, and the sensors continuously read these trigger wheels to determine the exact location of the shafts in their rotation. Finally, there is a sensor that tells the computer how efficiently the engine is operating. Ideally, the system will deliver just the right amount of fuel and air to the engine and will burn all of the fuel and air completely. No fuel will be wasted. By having a sensor in the exhaust pipe, the computer can monitor if the engine is burning all the fuel-air mixture completely. The oxygen sensor performs this function and tells the computer if there's too much fuel or air in the mixture. The computer can adjust the amount of fuel up or down to correct. Now let's talk about the outputs of the system. First are the fuel injectors. The computer controls the injectors by opening and closing them hundreds of times per minute. The amount of time the injector is open is called the pulse width. The computer increases the amount of fuel entering the engine by extending the pulse width, meaning it holds the fuel injector open for a slightly longer period of time. It lowers the amount of fuel by decreasing the pulse width. Next are the ignition coils. The computer fires the ignition coil for each cylinder with precise timing. As engine operating conditions vary, the coil might need to be fired slightly sooner or later. In the old days, advancing the ignition timing was done via mechanical or vacuum controls. You probably heard of the vacuum advance system used on older cars. But today, this timing adjustment is performed electronically by the computer. It will fire the coil sooner based on certain operating conditions, such as high RPM. Many vehicles use a knock sensor as an input to determine if the timing is being advanced too far by the computer. This knock sensor picks up the vibrations from the engine that many of us would call pinging. If it senses excessive pinging, it tells the computer to adjust the ignition timing accordingly. This adjustment is critical to operate the vehicle at maximum efficiency. Now that we understand the components of the OBD2 system, let's move on and talk about how to communicate with the system and how to diagnose problems within the system.